All right, boys and girls, welcome back to the drive-thru for a slow Monday Slow Jams edition. This is 3-1, as always, sponsored by the deli. Hungry? Stop by the deli and get yourself a sandwich. You know, I'm not even creative enough to make a sandwich right now, so although I had a lot of sandwiches yesterday from Jimmy John's and they were good. All right, so here's what I want you to understand. Here's where math came from, okay? Math wasn't like exactly invented. It was always here. And so there's always more that you can kind of figure out how to use. So, like, you know, someone was making something in the caveman days, or maybe not the caveman days, like the Polynesian days, and they were making money off of that thing. So they started out, they were in the hole because they had to spend money in order to make money. So they spent money and they bought some rocks. I don't know how you bought rocks back then, but this guy figured it out. Okay? And then he cleaned those rocks and started selling them. So at some point right here, he went back and broke even. Okay? And then, you know, obviously, as he sold more and more rocks, he made more and more money. And then someone else was like, oh, I found gold. Now, it takes me a lot more money to find this gold. I have to dig for it. It takes more time. So he started out way more in the hole than the other guy. Okay? But then he figured out that he could sell the gold for more than he could sell the rocks. So he had a higher slope for his gold. Okay? So then all he's got to figure out is, well, where's my break-even point? At what point should I stop getting out? Should I get out of the rock business and get out of the gold business, okay? And that's literally like where these things came from in algebra. They were just useful. People could say, all right, well, if I could come up with, I don't know what this would be, 1,000 pounds maybe? If I could come up with 1,000 pounds of gold, then I should stop selling rocks and I should start selling gold, okay? So that's what you're essentially doing today. What you're doing is solving systems of equations by graphing. You've done this before, but what's more important to me is you know what you're doing. You've got two lines. Okay, now how far do lines go on? They go on forever. So there's only 3 scenarios that you can have for these lines. Okay? The lines could be parallel. And if they're parallel, they're going to go on forever and they're never going to touch. So lines like that will have no solutions because they don't intersect with each other. There's no point. So think about this like you're both selling gold, but this guy, his dad sold gold, so he started out rich. Okay? And this guy, he had to mine for his gold, so he started out broke. Actually, worse than broke. He owed people money. Well, if they sell the exact same amount of gold the exact same amount of time, this rich guy's always going to have more money than the guy that had to find his own gold. Does that make sense? So there are no solutions in that scenario. The second scenario is one that doesn't happen very often in real life, but it'll be disguised in your math class. You guys probably have a good idea what that line looks like. You don't have as good of an idea as what that line looks like because it's not in y equals form. So let's say we had these two lines. Y equals 2x plus 1. What's the y-intercept there? It's 1. What's the slope? Good. Up 2 over 1. So that line's going to look like that. Well, in order to graph this, I'll divide everything by 4, and you get, oh, lo and behold, you get y equals 2x plus 1. So this blue line is the exact same line as the black line. So when you get that, when the equations give you the same line, you will say that there are infinite solutions. Does that make sense? Okay? And then there's the case that we'll get started with, and that's the normal case when there's just one solution. One point where the lines intersect. Okay? So we're going to start with number 1. We'll call each of these times. This is what's nice about some of the new graphing calculators you guys have, is that they have different color graphs, which is nice for you guys. Hey, you're always welcome to use your graphing calculator in here. So if you want to just pop these things into your graphing calculator and copy them onto the paper, that is totally fine with me. I'm not going to make you buy something and then not let you use it, okay? All right, the blue equation. What is our y-intercept? It is 4. What is our slope? 2. So over 1, up 2, over 1, up 2, left 1, down 2. You definitely want to use a straight edge here because you're going to be trying to very accurately look for where these two lines intersect, okay? Although, if you use your graphing calculator, then you don't need to use a straight edge. The second equation has a y-intercept of -3 and a slope of -5. Remember, that means it should be going down and to the right. So if I go left 1, oh, there you go. There's my intersection point. Okay? Now, very important in this section that you read the directions. Unfortunately, I've omitted them from this slide, but you've got your worksheet right in front of you. It says solve each equation by graphing or using a table. Check your answers. So, when it says solve, we need to write down the solution. So what is the solution to these two equations? Very good. -1, 2. That's the actual answer to the question. We graphed it to find the answer, okay? Bless you. All right, now a harder version of the same exact challenge, okay? Now we're graphing things that aren't in y equals mx plus b form, but luckily we had practice on this. So I would recommend that you use the intercepts. Look, I'm going to write these out, but you guys are smart enough that you don't have to. I just don't want to confuse anybody. So, once again, there's the red one, or there's the blue one, there's the red one. Here's how I would solve these. Put a 0 in for x. You get 0 plus 3y equals 9. So what's y equal? Y equals 3. Okay? Now, put a 0 in for y. This is what I'm saying you could do in your head. You get x plus 0 equals 9. So what will x be? 9. So you know that it contains the point 0, 3 and 9, 0. That's kind of a bummer, but I think we can still make that work. There's 6, 7, 8. There's 9, 0 right there, right? Straight edge, graph. Okay, so now I'll do the same thing for my red. Put in a 0 for x. You get 0 minus 6y equals -18. -18 divided by -6. What do you get? Negative divided by negative. +3. Good job. Okay, so now we have that point. Oh, there we go. There's our answer. But I'll keep going because it won't always be that easy. Okay. Now what am I going to do as far as the process? What am I going to put a 0 in for now? Put it in for y. You get -2x minus 0 equals -18. -18 divided by -2. X is +9. Hold on. Right? Excellent. Excellent. We got this figured out. So look what happened. They had the exact same x and y intercepts. So this is one of the rare cases. And what's our answer here? Infinity solutions, or infinite solutions. So, that was a good one to do because it was a harder graph and it was a weird answer. You good with that? Okay, now, we got to get to the point where we're not skipping questions like these anymore. Because this is why you're in school. The math doesn't matter at all. The algebra, you're probably eventually not going to use it. But your boss is going to come up to you someday and tell you words. It's going to be a word problem, I promise. He's going to tell you that he needs you to do something for him or her. And she's just going to expect that you get it done, you get it right, and then it's well done. And if you do that, then you'll get more opportunities to do things, then you'll get better jobs, then you'll get bigger cars, and then, you know, you could have more fun maybe. Got it? We're only here to get ourselves the most options that we possibly can. So, stop skipping the word problems. All we got to do is write out a system. We don't have to solve it. Each morning you do a combination of aerobics which burn about 12 calories per minute. Stretching is 4 calories per minute. Your goal is to burn 416 calories during a that's kind of a random goal. I have to burn 416 calories today. How long should you spend on each type of exercise to burn off the 416 calories? All right, so totally okay if we don't get this right, but we just have to do our best, okay? Let me call A minute of aerobics and S a minute of stretching. Okay? I know that A plus S has to equal 60. That's one of my requirements, is that I need to work out for 60 minutes. Now, how many calories do I burn with each aerobic minute? 12. So if I do 12 times A, and I add up 4 times S, what do I need that to get to equal? 416. Okay, and that's all you're doing. You're not even solving this. Although we could, and we will, but not on this one. Got it? Okay, almost done with the video. The directions for number 9 say, without graphing, does each system have 0, 1, or infinitely many solutions? Well, this is all you got to do is get these equations to look the same. Okay? So, let me take this blue equation here, and let me write it in the form y equals mx plus b. So, 4y equals, so I'm going to subtract 8 from both sides. I'm solving this thing for y. So 4y equals 12x minus 8. Next step, divide by 4. You get y equals 3x minus 2. I got to divide everything by 4. I shouldn't have skipped that space. So I end up getting the blue equation is y equals 3x minus 2. Okay? For our red equation, it's a lot easier to solve. What do I have to do to solve the red one for y? Add 5. And you get y equals 3x plus 5. Now we can compare these things. Would you say that these lines are intersecting at one point, intersecting at infinity number of points, or that they're parallel and they will never intersect? They are parallel. What indicated to you that they were parallel? Same slope, awesome. And a different y-intercept, right? Because if they were the same slope and the same y-intercept, then we would have infinity solutions. infinite solutions. So this has no solutions. That's what you're going to write for your answer. Here's another little hint. Did I tell you you could use your graphing calculators on this? So you could just graph these things in your graphing calculator. The problem is they're not in y equals form. Okay? All right. That's it. Everything else on here you should be able to do. Have a good day. Boom!